All right, so today we're starting a chapter on systems of linear equations. So the good news is you know quite a bit about linear equations. When you graph a linear equation, what shape is it on your graph? It's a straight line, okay? So that's going to be nothing new in this chapter. You know how to graph a linear equation, except now you're going to graph two equations on one graph. And we'll talk about how that's beneficial and why we do that in just a minute when we do our modeling real life example. All right, so what is a system of linear equations? It's two or more linear equations that have the same variables. All right, so in a system, my x value, remember in the last chapter how x would stand for, t-shirts. We'll do t-shirts since we were just talking about t-shirts. X could stand for t-shirts and Y stands for dollars. Remember how we talked about that? So in a system, in both equations, X would stand for t-shirts and Y would stand for dollars. All right, so they have the same variables that mean the same thing. The solution to a linear equation is an ordered pair that can make all equations, or in this case for pre-algebra, both equations, because we're only going to do two, in the system true. Okay? All right, that'll make more sense once we start doing a couple of these. So, example 1. I'm going to solve the system by graphing. So my first question is, are these equations ready to graph? Are they ready to graph? So this part is review for you guys, right? Because you just had your test yesterday. Are these equations ready to graph? Yes, they are in slope-intercept form already. So on my first equation, I want you to go ahead and plot where your first point would go. On that top equation, where would your first point go? All right, you guys got that? Where did you plot it? On a y value of 5. Very good. Then somebody raise your hand and tell me, where do you go from there? How do I get to my second point now? Can anybody raise your hand and tell me? Mikhail. I'm going to what?
Rise.
Okay, rise 2, but then 2 isn't over any number, so how many do I run?
1.
All right, so I rise 2 and I run 1 and I plot my point. Now, with systems, it's going to be really important to use a straight edge to draw your line. And for some of you guys, you've been drawing kind of short lines. I need you to draw a long, like the length of your badge, okay, lined through these 2 points. All right, and draw it as straight as you possibly can. I don't know if that's going to be straight enough. Nope, hold on. It's going to take me a minute. All right, so one of the, I don't want to say annoying, but it is kind of annoying things about graphing is if you don't get it exact, which mine already is not lining up to be exact. If you don't get it exact, the answers don't really line up, but we'll talk about that in a second. All right, so now let's look at the second equation. All right, so everybody together, tell me where your first point goes on the second equation. -1, and then where do you go from there? Down 4, and then over 1. So you're going to follow your slope, -4 over 1, just like we did in the last chapter. So now we're going to go down 4 over 1, plot our point, and now we're going to draw a straight line, again, as straight as we can. It's tough to do on the iPad, but give it my best shot. All right, okay, as straight as you can until the lines intersect, all right, until they cross. So what I want you to remember, all right, because it's been a while since we talked about what these lines mean on the graph. The green line and the purple line, they actually highlight all of the solutions. Okay, so they actually highlight all of the solutions. So this green line right here, this is all of the solutions to my second equation. The purple line is all my solutions to the first equation. But there's one solution that is actually a solution to both equations. All right, that's what's new here. This is what's different than what you've done before. That solution is the ordered pair where the lines cross. All right, so I know it's not quite exact, but what point is it really close to? I go left 1 and up 3. It's really, really close to -1 up 3. All right, so I know you might be thinking, and if you're not thinking it yet, you will be. Well, what if my line is like a little bit off? Am I going to get the answer wrong? All right, on your quiz and your test, it'll be a lot clearer. And I'll explain more in a minute on the next example. But don't worry about that, okay? As long as you're really, really close in the right vicinity, you're okay. My solution is -1 up 3. So what does this mean? Okay, this is my ordered pair solution. This means, and I'm only going to do this on the first one, but I want you guys to understand what this ordered pair means. If I plug in my x and my y values from the ordered pair into either equation, it will make it true. All right, I'll show you. -1, let's plug in for x. 3, let's plug in for y. And let's see if it makes it a true statement. So 3 equals 2 times -1 plus 5. What's 2 times -1? -2. What's -2 plus 5? 3. So it works. Now, that's not necessarily anything special. But the fact that the same ordered pair could now be a solution to a second equation, that's not going to happen often. Okay? So that's why there's only one solution or one point where they cross. So let's try it on the second equation. Plug in -1 for x and +3 for y. So 3 equals -4 times -1 minus 1. What's -4 times -1?
4.
+4. What's 4 minus 1? 3 again. So what I want you guys to realize, my solution, this ordered pair, makes both equations true. Okay, do you see that? All right, how are we doing so far? Plot the lines, see where they cross. Not too bad? Okay, so we're actually going to skip the next one, and we're going to do the first one from example 2. Okay, so I want you to go down to example 2 now. What do you notice? Somebody raise your hand and tell me. What do you notice that's different about this system? Emily?
One of them is not ready to finish.
Very good. One of them is not ready to graph. Is that what you guys were thinking? One of them's not ready yet. Okay, so the top one, is that one ready?
Yes.
Yeah. Now we need to get the bottom one ready to graph. So let's go ahead and get that in slope-intercept form. All right, so where does my heart go? Above the 2, around the 2y. How can I get -x to cancel to the other side? Plus x to both sides. Okay. Now I get 2y equals x minus 4. All right, one more step to solve. Michael, what would be my last step to get y by itself?
Divide by 2.
Yep, divide everything by 2. So for my second equation, y equals, what number is understood in front of the x?
1.
All right, so don't forget that's going to be 1 over 2x. Would it be plus 2 or minus 2? Minus 2. Okay, so now what I want you to do is I want you to graph the first equation and the second equation. Go ahead and plot those points. Remember, use your badge for a straight line. Okay, if you try to freehand it, there's no way to make that line straight. So the easiest thing to do, everybody's wearing a badge, just use the straight edge of your badge. Okay, so let's see what happens on this one. Now, this question is more similar to what you're going to see on a quiz or a test, and you'll see why in a second. All right, because like I said, on the last one, it was like, did I get the points right lined up perfectly? So where did my first point go on the first equation? -2, and then where did I go? Up 2 over 1. Did you guys go up 2 over 1? Did you follow your slope? Okay, and then we draw a straight line through those points. Nice long straight line, because we don't know where they're going to cross. Now on my second equation, where does my first point go on my second equation? Where does it go, guys? On a -2 again. So this is really nice because if they share the same point, guess where they're going to cross? On that point. So there's no guessing, right? I know they're going to cross through, but let's go ahead and finish the line. Now, where do I follow this slope? I go up 1 over 2. Okay, so I go over 2.
That's what I did.
Yes, so now,
1/2.
right. So now my second point goes here, and I draw my straight line through those 2 points. Okay, but because both of the equations shared a point, there's no doubt where they're crossing. Yes, they're both crossing through 0, -2. All right, and if you were to plug that back into the equations, it makes both of them true. So your solution is 0, -2. This is the solution to your system. Okay, what do I mean by that? If you were to plug these values back into the original, okay, on both of them, it would make it true. It's a solution to both. All right, so now let's do one more example. This example is really important because it's going to help you understand why in the world we do a system of equations in the first place. All right, so I want you to imagine that you're planting 2 plants in your flower bed, okay, at your house. All right, so you observe the heights of 2 plants. Plant A has a height of 8 centimeters and grows 1 centimeter each week. How tall is plant B? Plant B is how tall? 4 centimeters. But plant B grows 2 centimeters each week. All right, so I want you to think. So we're going to pause here for a second. Did you know that a newborn baby, all right, so when you guys were first born, a newborn baby in their first year of life triples its weight on average. So say you're 8 pounds when you're born. By the time you're a year old, you're about 24 pounds. Okay? So I want you to think of how much you weigh now as a 7th grader. All right? What if your weight tripled in the next year? Right? So most of you guys weigh like around 100 pounds, give or take. You want to be 300 pounds, that's it, right? So your growth changes, right? Okay, and your starting growth changes. So what's happening with these plants is plant A starts at a height of 8 centimeters and plant B starts at a height of 4 centimeters. But guess what's happening? Plant A is growing slower than plant B. The rate is different. So I'm going to write this in an equation and I'm going to see, all right, so plant B started off shorter, but it's growing faster. Will there be a point where they're the same height? Okay, probably. Now, if they were growing at the same rate, are they ever going to be the same height? No, they're going to be parallel. That's why same slope is parallel. All right, so we're going to use the equation y equals mx plus b. I want to remind you, b is your starting value. It is not a rate. It's not something that's continuously changing. All right, so for plant A, what would be your B value or your starting value? 8. All right. Now, 1 centimeter each week, that is a rate. That's something that's continuously happening as the weeks go by. Does that make sense? So I'm going to plug it in. Y equals 1x plus 8. All right. So again, 8 doesn't have a variable with it because it's just that's the starting height. So now what I want you to do is I want you to write an equation right underneath that equation for plant B. So we have the equation for plant A. I want you to go ahead and write the equation for plant B. Okay? All right, can you guys do that? All right, go ahead and write your equation for plant B. Anybody have what they think the equation is? All right, Zoe, what do you think? Y equals 2x plus 4. And again, just by looking at these equations, I know that the lines are not parallel, right? Because they have different slopes. So at some point, they're going to intersect. That's what I want to see on my graph. So I want you guys to go over to your graph. And I know that the grid lines look like dots, but you can still count the units. All right, so let's go ahead and graph the first equation. What is my starting height or my starting value for the first equation? 8. All right, so again, I want to interpret this for you guys. That means after 0 weeks, meaning right when I first planted it, the height is 8 inches. All right, so my y-axis here, this is my height. Okay, all right, so then how much is it growing per week? 1 inch. So I rise 1 and I run 1. All right, now I'm going to draw my straight line as straight as I can through the points. Not straight enough. Nope. Third time's a charm. Close enough. Okay. All right, draw the line pretty long because you don't know where it's going to cross. Okay, now I'm going to do my second equation for plant B. What was my starting height for plant B? 4. But what is plant B's slope or rate of growth? 2 over 1. Okay, so it's a little bit of a steeper slope because it's growing faster. All right, now I'm going to draw my straight line. Oh man, it was so close to perfect. Not quite though. Okay, my straight line through. So now, at what ordered pair are they crossing? At what ordered pair? What is that ordered pair where they cross? They cross at what? 4? 12. Okay. Now, I heard 3 and 13. In first hour, a couple people got 2 and 11. Like, really close, right? Okay, so just get it as close as you can. As long as you get as close as you can and you can interpret the answer, I'm not going to take points off. All right? So, will the plants ever have the same height?
Yes.
Yes. How many weeks? After how many weeks?
4.
All right? After 4 weeks, both plants will be how tall? 12 inches tall. Okay, do you see how we did that? All right, X stood for weeks, Y stood for height, so I can interpret my answer. After 4 weeks, they're both going to be 12 inches tall. Then on week 5, which plant's going to be taller? On week 5, plant B. Plant B is going to be taller than plant A. So it's going to take 4 weeks. They're going to be the same height. And then plant B is going to end up being taller. Okay? All right. So that's everything you need to know for the first section.